Hey guys, in this video I'm gonna show you how you can count coins in an image using Python and OpenCV. So let's begin. First we'll be importing three libraries. One is OpenCV, second is NumPy if we'll see if we need it or not. The third one is Matplotlib. Then we'll read the image. So here we'll use cv2.imread command to read the image. Then what we'll do is we'll convert this image into a grayscale image. To display our image we'll be using Matplotlib's pld.imshow function. Now since our image is a grayscale image, so we'll be using cmap equals to gray parameter. Now you can see we have displayed our image. Now to count the coins in an image we'll have to detect the edges. But before detecting the edges we'll have to make the images blur in order to avoid detecting the noises. So we'll be using Gaussian blur function. So here the first parameter is nothing but our input image, and the second parameter uh, is the size of the kernel window, which will hover over the entire image and calculate the central pixel value using the Gaussian algorithm. And the zero value is the standard deviation. So here 0, if we keep this value as 0, so it will calculate the standard deviation on its own. So we don't need to worry about the calculation of standard deviation. So if we increase the size of this kernel, so the image will become more blur. So let's see how our image shows up after making it blur. So you can see we have blurred our image. Now we'll be using a canny edge detector algorithm for detecting the edges. So here the first parameter is our input image, which is this one. So we'll be using this image and not this for the first image, okay? Because we don't want to capture the noise, right? We only want to capture the edges of the coin. So this is the first parameter. Second parameter and the third parameter is the minimum value and the upper value of the threshold. So a canny edge detector will calculate the values of the edges, and if any edge has a value less than 30 it won't be considered as an edge, and if any edge has a value above 150 it will be counted as a short edge, and any value that lies between 30 and 150 will be considered as an edge, depending on if it is connected to the edge which has a value greater than 150. Alright, and the fourth parameter is the kernel size of the Sobel filter, which will be calculating the edge. So 3 is a default value actually. Now we'll see what will be the value of this output. So you can see we have successfully detected the edges. Now let's proceed further. Now we can see that the edges are not connected. So we need to connect the edges. That is, we have to make the edges thicker and more visible and more connected to each other to fill in the gaps. So we'll be using dilate function in CV2. So our input image, the size of the kernel, and the number of iterations. Now if you see, the edges are more clear now. So what this kernel size and dilate function does is it will move this kernel across the entire image, and if under that window any white pixel falls, so it will make the other pixel white as well, and we repeat this process twice. So hence iteration is equal to 2. So now we can see the edges are more clear now. So now next step is to calculate the contours. So now we'll find the contours in the image. The first parameter is our input image. Second parameter is cv2.ret or external. Third parameter is cv2.chain approximate or null. We'll use none. So the second parameter ret or external means that we'll be considering only the external contours and not the internal ones. And chain approximate is how we'll be calculating the contours. It means that we'll be considering each and every point on the of the edges to calculate a contour. Now once our contour has been calculated, we'll draw the contours on our image. So before drawing the contours on our image, we'll have to convert our input image into RGB image, because CV2 reads image in BGA format, and Matplotlib reads image in RGB format. So we have to convert a PGR into RGB. If you want to know the difference between the PGR and RGB images, you can refer one of my videos. Now we'll draw the contours on our image. So the first parameter will be our input image, second parameter will be the contours, third parameter will be how many contours we have to draw. So we will want to draw all the contours, and fourth parameter will be the color of the contours, so we'll consider green color, and the last parameter is thickness. So let's display our image plt dot image of function. So we won't be using CMap now over here. So here you can see we have drawn the contours. So now let's count the points in the image. I'll just write here a simple statement. Points in the image 24. So we have counted 24 points in this image. So let's verify 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have successfully counted right number of points in the image. I hope you found this video helpful. Don't forget to subscribe. Thank you very much.